Let's talk about a planet that's more like a celestial monarch, a beast so grand it nearly became a star itself. It's a world of complete contradictions. It's ancient, but it's furiously fast. It's beautiful, but it's unbelievably violent. So let's dive into the story of Jupiter, the undisputed king of our solar system.
To really get a handle on this king's domain, we have to start with scale. And forget charts and graphs for a second. Just picture this number, 1,321. That's how many Earths you could cram inside of Jupiter. It's not just big, it is a completely different category of existence.
And here's where things get really wild, that contradiction I was talking about. Jupiter is the oldest planet in the neighborhood, showing up just 1 million years or so after the Sun. It's the ancient patriarch. But, and get this, despite its colossal size, it spins faster than any other planet. A full day on Jupiter is less than 10 hours long. It's a dizzying, frantic giant. And that contrast, that's what makes it so fascinating.
So first up, let's really establish its royal status. I mean, how dominant is Jupiter really? Its influence isn't just about being big, it's about the pure, raw power of its gravity, which has literally shaped the architecture of our solar system.
Okay, check this out. This chart says it all. That bar on the left, that's Jupiter's mass. Now look at the one on the right. That represents all the other planets, Saturn, Uranus, Neptune, Earth, all of them combined. And Jupiter's more than 2.5 times more massive. It's not just another planet. It's the gravitational anchor that everything else kind of has to dance around. And if that last slide didn't convince you, this fact is just brilliant. You know how we think of planets orbiting the Sun? Well, it's really more like two partners spinning around a shared center of gravity. For every other planet, that spot is deep inside the Sun. But Jupiter is so huge that the shared center of gravity is actually outside the Sun. So in a way, Jupiter doesn't just orbit the Sun. It makes the Sun itself wobble.
Now, let's talk about its looks. Because if Jupiter is a king, its atmosphere is its royal robe, a chaotic, swirling, violent expression of its inner power that we can actually see.
NASA really put it perfectly here. It is a tapestry. But these aren't just pretty patterns. We're talking about planet-sized weather systems. Every single stripe in every spot tells a story of incredible chemical and physical forces churning away.
So what are we actually seeing in those stripes? Well, they're clouds made of ammonia and water vapor. The dark bands are called belts, and that's where gas is sinking. The lighter bands are zones, where gas is rising. And the lines between them? Those are ferocious jet streams, ripping along at over 335 miles per hour, way faster than the most powerful hurricanes on Earth.
And of course, we have to talk about the main event, the most famous feature on the whole planet. It's not just a storm, it is the storm. The Great Red Spot. It's basically a hurricane, an anticyclone, that's bigger than our entire planet and has been raging for at least 300 years that we know of.
But here's the thing. This giant storm has a mystery. As you can see on this timeline, it's shrinking. Back in the late 1800s, you could have fit 3 Earths inside it. Now, it's closer to just 1. But while it's getting smaller horizontally, the Juno mission recently found something absolutely astonishing. Look at that last point from 2021. It's incredibly deep, plunging 300 to 500 kilometers down into the atmosphere. It's less of a spot and more of a colossal crimson vortex.
So what's going on underneath all those violent clouds? Okay, let's take a journey deep into Jupiter's bizarre and extreme interior. It's a place unlike anywhere else in our solar system.
First things first, you have to get this in your head. You can't land on Jupiter. It's not possible. There is no ground to stand on. If you tried, you just fall, descending through denser and denser layers of gas and liquid into a realm of crushing pressure and frankly unimaginable temperatures.
Let's just imagine that descent for a second. First, you'd fall through the outer atmosphere, those ammonia and water clouds. As the pressure builds and builds, that gas compresses into a gigantic ocean of liquid hydrogen, literally the largest ocean in the solar system. Go deeper, and the pressure becomes so intense it actually strips the electrons from the hydrogen atoms, creating this bizarre, electrically conductive fluid called metallic hydrogen. And at the very center, we used to think it was a solid ball. Nope, scientists now call it a fuzzy or dissolved core of heavier stuff.
And that weird layer of spinning liquid metallic hydrogen we just talked about? That's the key to another one of Jupiter's superpowers. It acts like a giant dynamo, creating a monstrous magnetic field, anywhere from 16 to 54 times more powerful than Earth's.
This magnetosphere is the largest single thing in the solar system. It's so big that if we could see it with our eyes, it would look bigger than the full moon in our night sky.
Now, a king's powerful gravity doesn't just shape the planet itself, it holds court over a huge family of satellites. It is truly a miniature solar system all on its own.
And I mean a huge family. As of right now, we've confirmed 97 moons orbiting the gas giant. And that number just keeps going up. The sheer number of them just shows you how completely Jupiter dominates its corner of space.
But among all those moons, 4 of them are the real crown jewels. Galileo found them way back in 1610, and they are entire worlds in their own right. You've got Io, which is the most volcanically active place in the whole solar system. Then there's Europa, hiding a giant liquid water ocean under its ice. Ganymede is the biggest moon in the solar system. It's even bigger than the planet Mercury. And then there's Callisto, this ancient, battered world that's like a relic from the early days.
So why are these moons so active and interesting? Well, the answer is Jupiter itself. The planet's insane gravity is constantly pulling and squeezing on them. This constant flexing, this tidal force, generates heat inside the moons. That's what fuels Io's endless volcanoes, and most excitingly, it's what's keeping the ocean under Europa's icy shell nice and liquid. For everything we've learned, you'd think we have Jupiter all figured out, right? Not even close. In fact, our exploration has really only raised more profound and compelling questions that scientists are now desperately trying to answer.
And we have our best robotic explorers on the case. NASA's Juno is in orbit right now, mapping out Jupiter's gravity and magnetic fields. The European Space Agency's JUICE mission is on its way to check out those icy moons. And NASA's Europa Clipper just launched with a very specific job: investigate whether Europa's ocean could actually harbor life.
One of the biggest puzzles is still the weather. We see these crazy, powerful jet streams on the surface, but how deep do they actually go? Juno's data is suggesting they reach thousands of kilometers down, way deeper than anyone thought. Figuring that out is key to understanding the engine that drives the entire planet.
And another huge mystery is right at its heart. Like I said, we used to think Jupiter had a small, solid core. Now we know it's this fuzzy, diluted mix of rock and hydrogen. How did it get that way? Was it born like that, or did something catastrophic happen early in its history? The answer could completely rewrite how we think planets are formed.
But you know, maybe the most profound question that Jupiter poses for us doesn't have to do with the planet itself, but with one of those little worlds caught in its immense gravitational pull. I mean, think about it. After all of our searching across the cosmos, could it be that our best chance of finding life beyond Earth is right here in our own solar system, swimming in the dark, liquid water ocean of Europa, kept warm by the incredible power of the King of Planets? That's the question that